This video focuses on finding the perimeter and area of similar figures. When we learned about similar figures, we learned about something called side ratios. What makes figures similar is that their corresponding side lengths are in proportion. But when I look at what's going on here, I've got polygon 1 and I've got polygon 2. If we know they're similar, that means the ratio A to B will be the same ratio for all corresponding sides. So if C and D are corresponding sides and these figures are similar, that means C over D will make the same ratio, and so forth all the way around, right? E equals F. And the fourth side as well. So this we already kind of know. We have seen this before. And the side length doesn't just mean side lengths. Anything that is measurable in a single unit, so something that you can use a ruler or a tape measure to measure, will have that same ratio. So if I wanted to draw some diagonals here, like say this diagonal and that one, they also would have that same side ratio, also called a scale factor ratio. Perimeter is made up of summing up sides. So that means that the perimeters will also be in that same ratio. So this is something we've done in the past. Now, what we're learning today is that it is true that side lengths and scale factor ratios work that way for similar figures. Well, if you want to know something about the area of similar figures, you can find that scale factor ratio and square it. And that relationship is true when you're looking at the areas of these figures. In this example over here, I'm given two similar triangles. It says find the ratio of the perimeters of the red triangle to the blue triangle. Well, if we would have to find the scale factor ratio or the side length ratio, I'm going to call it SF ratio for scale factor ratio. And BC and EF, those are corresponding sides, just one is kind of turned over and flipped. So the scale factor ratio is 8 over 12. And like all fractions, you want to write this ratio in simplest form. So divide top and bottom by 4, get a ratio of 2 to 3. That's the scale factor ratio. But the perimeter is just adding up sides, so it's going to have that same ratio of 2 to 3. So the perimeter ratio will be that same ratio of 2 to 3. If we want to find the ratio of their areas, the first thing you do is you find their scale factor ratio, which we did. The scale factor ratio is 2 to 3. So to find the area ratio, that is, whatever the area of this one is and whatever the area of that one is, you can find that ratio, A1 over A2, by squaring this thing. So when you square a fraction, you square the numerator and you square the denominator. So the ratio of the areas of the figures will be 4 to 9. So let's look at some examples here. The perimeter of triangle ABC is 24 feet and the area is 24 square feet, which that can happen. And we know the perimeter of another triangle, JKL. So let's draw it first. So just draw two triangles. Here's my triangle ABC. Here's triangle JKL. And let's see, what do I know? The perimeter of this one, call it piece of 1, is 24 feet. And its area is 24 square feet. That's area 1. Perimeter 2 for JKL is 36 feet. And what is its second area? That's basically what we want to find here. First thing you do is you find the scale factor ratio, which is if you know a side length, set of corresponding side lengths, use that. In this case, I know perimeters. So to find that ratio of perimeters, perimeter ratio, I'm going to go left to right here, small to big, which is 24 to 36, which I can reduce, getting a ratio of 2 to 3. And so the ratio of areas, let's just put that in 2 to 3, will just be the square of that. So I'm going to square that fraction 2 to 3 to get 4 over 9. And then I'm going to use that ratio to set up a proportion with areas. So I want A1 to A2. That's the ratio I want. So that A1 is 24. A2 is the thing I don't know. And because I'm working with areas, I'm going to use this area ratio. So that is in the ratio of 4 to 9. And then you just solve this proportion. So I'm going to solve this proportion by using a cross product. So 4 times x will equal 9 times 24. And okay, so I can divide both sides by 4. I'm going to get this x, which is my area 2, to be 54 square feet. The trick here is to understand the relationship, the side ratios. If you know that, you can square it to get the area ratio. And if you were missing an area, but you know the area of one of the pieces and you know the ratio, you can use that area ratio to find missing areas, even if you don't know all of the information. Like I don't have a base and a height and all those things that we use to find areas of triangles. So it's a nice little way to get there. Okay, let's see. The ratio of the area of two regular decagons is 20 to 36. What is the ratio of their side length in simplest radical form? I always label what I'm looking at. It can get confusing. So the area ratio, I'm just labeling what they told us. It's 20 to 36. Now, this should be in simplest form. I don't know why they didn't give it to us in simplest form, but I'm going to put it into simplest form. They have a common factor of 4. So divide top and bottom by 4. You get 5 over 9. That's my area ratio. If I know that and I want the side length ratio, the relationship is going side to area, you're going to square the side length ratio. So if you're going backwards, you're going to take square root. So it's just going to be you take your area ratio and you take the square root, and that would be the side length ratio. So square root of a fraction is the square root of the numerator, which that's just the square root of 5, over the square root of the denominator, and the square root of 9, perfect square there. So that's just square root 5 over 3. So what is the side length ratio or the scale factor ratio? It's the square root of 5 over 3. I'm given two similar figures here, and I want to find the area of the smaller one. So the area is the thing I don't know, but I do know the area of the second one. I also see some corresponding sides, so I can actually figure out the scale factor ratio or the side length ratio, and that would be 7 over 9. So from that, I can square that to get the area ratio. So square top, square bottom, that's 49 over 81. That would be the area ratio small to big. If I want to find, let's say this one's area 1 and that one's area 2, if I want to figure out that ratio, well, the first thing is I don't know. And the second one is 210, but I know what it should be. Since I'm working with areas, I'm going to be looking at this one. Should be 49 over 81. And so now I'm going to solve that proportion. You get an equation, 81 times x equals 49 times 210. You're going to multiply 49 times 210, and then you're going to divide by 81. I did that, and it came out to be, to the nearest tenth, that comes out to be approximately 127 square inches. And that would be the area. Here's another example. Given these figures are similar, find the length of AB. So I'm going to put an X for the thing that they want us to find. I can see that corresponding bit, X over 4, that's my scale factor ratio. And that's not very helpful because I don't have the information to know what X should be. That's what I have to find out. But the area ratio, that is something I can find out because they gave it to me. So if this one's A1 and this one's A2, going left to right, I have an area ratio of 128 over 18. Now, it is very helpful to have this in the simplest form. I'm going to use my Desmos calculator to figure that out for me. I'm here in my Desmos calculator, and I'm just going to type in that ratio, which was 128 divided by 18, and I get a decimal. But if you look to the left, there is a circle with like two boxes over each other. That says turn that into a fraction. 128 over 18 is really 64 over 9, and I'm very happy to see those two numbers, mostly because they're perfect squares. So when I go back here, this is actually 64 over 9. And why does it matter that they're perfect squares? Because really what I'm trying to find out is the scale factor ratio so I can find the missing x value here. But if you know the area ratio, if you know the area and you want to go to the scale factor ratios, you're going to take the square root. So you're going to take the square root of 64 over 9. These both being perfect squares makes this very easy. So it's just 8 over 3. That is the scale factor ratio, which means now I can just set my x over 4 equal to that. And then fairly simple, cross product 3x equals 32, which means x is 32 over 3, which it's approximately 10.7 centimeters. And I'm just rounding to the nearest tenth, but you can round differently if you want. Okay, so that's how we can use these things. I do have some U tries here. So what I would like you to do is to pause the video right now, work them out, and when you finish that, go ahead and restart up the video and you can check your work. Go ahead, pause. Okay, we're back. If you haven't paused, then you're just cheating, giving you a last chance to go ahead and pause and give it a try, because you're really not going to learn unless you give it a try. But if you have, we're back. So let's see if we can figure out the answers to these questions. We're given two figures are similar, so triangle ABC and DEF are similar. Find the ratio of the perimeters and areas of triangle ABC to DEF. So you really need to read carefully here. When they tell you which way the ratio has to go, make sure you're giving your answer that same direction. So they're going here, it looks like a small to big kind of ratio. I know the area of ABC. It's 24, whatever units these are. And we want the area of the other one. So I'll call that one A1. And I want the area of the second one. So let's see if we can do this. So I can get a scale factor ratio here because I have two corresponding sides. AC does correspond to DF, and I have both those values. So that is 12 over 15, which can be reduced. So you could either use Desmos, or if they're simple ones like this, you can probably just do them. Divide top and bottom by 3. So that comes out to be 4/5. That's my scale factor ratio, my side ratio. So I want my area ratio, which will just be the square of that. So 4 over 5, you square that, you get 16 over 25. And that's the ratio that I expect for my areas. So I know one of my areas, and again, I'm going A1 to A2 because it said triangle ABC to DEF is 16 over 25. That is the area ratio. Right now I'm told area 1 is 24 square units. So I want to find what that second one is. So this would be the setup. I'll put that up here. We have 16x, I'm just doing a cross product, equals 25 times 24. I believe the x comes out to be 37.5 square units. I've got a large rectangular baking pan that's 15 inches long and 10 inches wide. Big believer in drawing pictures. So here's my large rectangular pan. It's 15 inches long by 10 inches wide. And I've got a smaller pan that's similar, so same proportions as this larger one. The area of the small pan is 96 square inches. Find the width. So I'm going to go with this being the width. Usually we think of length being the longer one and width being the shorter one, but we can figure out both if we really needed to. Well, I can actually figure out the area ratio here because in my larger pan on this side, I have enough information to find its area. Length times width, which is 15 times 10, which would be 150 square inches. So I can get an area ratio here. So the area ratio is 150 over 96, and I'm going I'm going big to small on this one. I tend to go left to right. I want to reduce that, but I'm too lazy to figure out what it is. So I'm going to use my Desmos calculator. I want to figure out what 150 divided by 96 is. So 150 divided by 96, and then I'm going to click on the fraction, make me a fraction button, and that's 25 over 16, which isn't that nice? They're both perfect squares. So this is the same as 25 over 16. So the area ratio is the square of the scale factor ratio. So I can take the square root to get the scale factor ratio. And I'm very happy that they're perfect squares because it makes that easy in this example. So take the square root of 25, take the square root of 16. That's the scale factor ratio. If I'm working with widths, right? Here's one width, here's the other width. So that's going to be in the ratio of 5 to 4. So 10 over W will be that same ratio. And I think it's pretty easy to see here that W would have to be 8 inches. That would be the width. Third example is actually quite a bit like the last one. We have a large rectangular billboard. It's 12 feet high and 27 feet long. And we have a smaller billboard, but it is similar, so it's the same proportion. And its area is 144 square feet. Want to find the height of that smaller billboard. So if you draw the pictures, hopefully you can see that this is very much like the previous example. I can get the area ratio because I can figure out this area. The area of the large billboard is 27 times 12. It's 324 square feet, which means I can now set up an area ratio. And I like to go left to right here, so I'm going to say 324 to 144, and I'm going to use Desmos to help me get that in simplest form. So I'm going to do 324 divided by 144 and make that a fraction. It's 9 over 4, which is good news because I want the scale factor ratio, which is the square root of that number, and that's a perfect square, so that's 3 over 2. So the sides are going to have that ratio of 3 to 2. When I find that x, it's going to be 12 over x is going to be in that 3 to 2 ratio. So I hope we can see here that that x would come out to be 8 feet. And then the final example here is I've got two similar rectangle. There's rectangle 1, and then there's rectangle 2. The perimeter of this one, rectangle 1, is 48 inches. And rectangle 2 is 30 inches by 18 inches. Find the area of this one. This one's slightly different than the other ones. For this one, I know one perimeter, but I can find the perimeter of this one. So the perimeter of rectangle 2, it's the sum of all the sides. So if this is 18, the opposite is 18. If this is 30, the opposite is 30. So we want 2 times 18 plus 2 times the 30. And if you work all that out, you're going to get a perimeter of 96 inches. And so this perimeter here is 96 inches. So now I can set up a perimeter ratio. And remember, perimeter ratios, they just end in inches. They're not square inches, right? Over here, they're not cubic inches. They're things you can measure with like a ruler or a tape measure. That's your scale factor ratio. It's made up of side lengths. So use the same side length ratio. If I go left to right like I like to, that's 48 over 96. And maybe you can see what that is reduced. But if not, you can go ahead and use Desmos calculator. And, if you see these, you don't have to use the calculator if you already see it. But that's my scale factor ratio. So I'm going to square that to get my area ratio. And I do like labeling this way because these numbers, they tend to start flying. It's just a way to organize your work. So I need to find that one's area. I guess I need to find this one's area too, right? But I can because the area of number 2 will just be 18 times 30, which is easy enough to find, 540 square inches. So now that I have one of the areas and I know the ratio, I can figure out what this one is. So I'll call this one x. So x over 540 will be in the area ratio of 1 to 4. So we can figure that out. 4x equals 540. That's just the cross product. So x would be 135 square inches. And that's basically all there is to it. I hope this has been helpful. Thank you for watching.